Hello and welcome to Book Bites, a book club podcast for developers. We're talking about 7 languages in 7 weeks, and this week we're talking about Scala. I'm Adam Garrett Harris, and I'm joined
I'm Jason Staten.
by Jason Staten.
Oh,
I
I'm walking all over you.
Mixed it up on you, though. So, I forgot to mention, I was going to actually mention on each episode how much time I spent on each of these, because I feel like it seems like a big commitment to read this book, and especially if you're going to go through the exercises, but it's really not, I feel like, especially for, trying to learn a language or learn something about it. So Ruby, I spent about 5.5 hours. IO, I spent about 7. Prologue, I spent 8. I think I spent more time reading that one, a little bit more time on the exercises. And then this one, Scala, I actually only spent 5 hours. And that's because I did not put a lot of effort into the exercises.
Huh. That is interesting. I don't have exact numbers for myself, other than I know that I spent far more time on Prologue, simply because it was such a departure from the daily.
Yeah, I did too. And even though it was such a departure, it was still really approachable. And so I could still do stuff with it. And I had a lot of fun just making little databases about things. So I got distracted and spent a lot of time making a database about the royal family.
Right. All right. So with Scala, tell me about your experience getting started with it.
Installing it, this is probably the hardest one so far to install. First, I tried to install it, and then turns out I needed GCC. I already had Java. And then I tried to install GCC, and it turns out I needed Xcode command line tools, and for whatever reason, I didn't have that, because I recently uninstalled Xcode to make more room on my Mac. And then I ran into a lot of issues where the code in the book didn't run. What about you?
Mine was not quite that painful. I don't know how you wound up having to go through GCC. I mean, unless, well, I don't know, maybe I had just the stuff installed and it happened for me. I went and got Scala and SBT, which is the Scala build tool.
I didn't get that.
I guess I knew about SBT from having worked with Scala in the past, knowing that it was kind of the thing that you use to build projects and pull in dependencies and so forth.
Huh.
And so I went and grabbed that, and it still seems like it's the tool of choice for managing a project in Scala. And initially I was like, okay, I actually have a copy of IntelliJ just for the case of pulling up a Java thing if I need it. And so I said, well, why not do the Scala stuff on it? And that kind of broke down on its, like, for me, at least the idea of SBT versus what IntelliJ was doing for me, it was just like a lot to go and consume at once. And I tried to get a testing library going with the Scala test, and that didn't work out with my version of IntelliJ, and I just backed out. And so actually went and just used SBT plus there's a VS Code integration called Metals that I figured I would try out, and that was pretty decent. Not quite as solid as some full-fledged IDE like IntelliJ probably would have offered, but I didn't feel like spending more time on getting tooling set up because I wanted to actually write Scala. So that was my setup, was VS Code with Metals and SBT to go and build and run the project.
Okay. Yeah, I just used Vim like I have been the whole time, and it was fine. Well, actually, it would throw whatever I'm using to show syntax errors.
Mm-hmm.
It would show errors for things that weren't actually errors, because I don't know. It doesn't know anything about Scala. I'm not sure how it was trying to show errors.
Maybe if you're using like NeoMake.
I think I'm using Ale.
Okay. I think even that, maybe there's recognition for Scala extensions even if you don't have a plugin for the syntax.
Yeah. Yeah, I'm not sure. But yeah, I thought I would really enjoy this language. And I remember going through a course on it before, a functional programming course, and it being really mind-bending, just the functional programming concepts, because it was the first time I'd ever heard of functional programming. And this time, I realized that Scala is this bridge between object-oriented programming in Java and a pure functional programming language. So it still has object-oriented programming and functional programming concepts. So it fully supports either paradigm. And that's a really cool concept, I think, to know that you can't get a whole bunch of people to just suddenly switch from one paradigm to another. You need an intermediary language that can allow them to stay in their comfort zone but explore aspects of another paradigm.
Yeah, I think that makes sense if you kind of want to like Trojan horse a big Java shop or something to say, hey, we're bringing in this new thing, but don't worry, it's still object oriented.
Yeah.
But you can kind of progress away from that.
I also thought it was really weird how a lot of the stuff under the hood is Java stuff, if that makes sense.
Yeah. I mean, I think that's a good approach to take, given that that's what they're built upon. So by embracing those underlying Java kind of primitives or standard library, it gives a stronger interop with the existing ecosystem, which I'm sure was especially important when Scala was starting off initially too.
Yeah, it just surprised. Like I knew that it ran on the JVM, but it surprised me to see errors or types with Java in the name.
Yeah, I think I ran into a few cases of the same thing when looking at it, which was all right for going and pulling up the docs on it. Then you just wind up in Java docs sometimes, or the Scala
really?
docs the other.
Okay, speaking of docs, what did you think of the documentation for Scala?
So I hinged a whole lot on the, I guess, help that came through kind of IntelliSense in VS Code. I think for me, I've found that while I am a lover of Vim when it comes to working in a static language, being in an editor that makes context readily available, like if you go and hover over app or like click on if you hover over some keyword or some type, you can see the definition of it or like go to it and read like all the fields of it.
Yeah,
it is really nice to be able to do that, and I haven't bumped into an equivalent experience inside of Vim. So
yeah,
using that, I was actually able to move through stuff without having to bounce around on the web or dig at online docs as much.
Okay. So my experience was I took one look at the documentation site because on day one it tells you to go find the API for Scala. And I took one look at it and I was like, nope. Like I clicked around a few times and I could not understand how I was supposed to understand and use those docs. And I wish I had used an IDE because I've been using an IDE for like a year and a half at work, moving over from Vim at previous jobs. And at first I didn't love it that much, but I definitely see how it's with statically typed languages. It's super useful, and clicking around and hovering over things and seeing what they are. It's super useful to just hover over and see what type it is and get auto completion and see what methods it has on it and what the parameters are supposed to be, what the return type is.
Yeah.
So,
It's really helpful, especially in the case of things being deprecated as well.
It seems like Scala deprecates things a lot.
It is true. At least a couple of exercises in this book required taking a very different approach. I think even right off the bat on the first exercises, you run into it.
Yeah. I remember in my days of writing Java during college that a lot of stuff in Java was deprecated and would say, don't use this, use this very similar sounding method instead. And it's like, why is it that method name instead of that method name? it seems very unfortunate that they had to change the name to something not as good just because they had to deprecate something old. And since I've moved away from Java, I don't see deprecations hardly, if ever, not within a language at least. And I work with JavaScript a lot, and they can't deprecate anything because it would break the web. So I'm very not used to deprecation in languages.
Yeah, it's I guess in JavaScript realm, like you said, I mean, there's a strong forcing function of keeping things around because people never upgrade, and like the sheer number of platforms that need to get supported, like they really can't eliminate stuff. Whereas when you are a language like that doesn't have to run like globally, but rather if you're running on top of the JVM or you're like a server side type language, then you don't have to fret about making a breaking change quite as much. I mean, obviously, like there are guarantees that come with it, and even in the book, Martin Odersky, the author of Scala, said that he would prefer to make some changes to Scala's ability to infer types, but that would come at a breaking change cost. So it is still something they have to be aware of, but not quite as extreme of a case of a language that will add features but never lose them.
Yeah. So right off the bat in day one, it has something like has you add an integer to a string, and in the book it works. Let's see, what does it do?
I think it just converts the integer to a string and then combines them.
Yep, it does. And then when I ran it, it said, warning, the method plus in class int is deprecated. So, and it's nice. It tells you which version since 2.13. It says add a number in a string is deprecated. Use the string interpolation, and it gives you the syntax for it. So that was interesting. But he was doing that in the book to make a point that even though Scala is doing type inference, it's still strongly typed. Because if you try to do 4 times a string, it doesn't work because it's expecting a number, some sort of number instead of a string.
Yeah, it knows how to convert it, and so it still falls under Bruce's definition of strongly typed.
Yeah, but it looks like they wanted to move away from that, I guess, where it's not just automatically converting an int to a string.
I would say that's pretty fair. Like I don't know how often you are actually adding a string and a number together.
No.
I mean, I think.
Sometimes maybe in the middle of a string, probably not right off at the beginning of the string. It could be like an error message where it's like for thing. I don't know. You're counting something up and putting it into a sentence.
Right. Yeah. I mean, I guess it's possible, but.
But you should probably be using string interpolation anyway.
With the multiplying though, I do believe that it's Ruby that you can go and say like any string you can say times 3 or like times some number, and it will actually just make that string that many times over.
Duplicate it over and over.
So if you give like the string of A times 3, it'll give you A back.
And I'm not sure why you would want to, but that's cool.
For making really terse code. Yeah.
For those computer science problems where you need to like print out a pyramid using asterisks.
Right. I don't know. Maybe there's like an equivalent string constructor in Java that's like make this string but use this character this many times over that is accessible.
Yeah, in other languages, you'd probably do something like create an array that's of this length where each item is this character and then join it together into a string.
Yeah. Or string builder it together or something. I don't know.
Yeah. So, I mean, it goes over some of the basic syntax, and it seems pretty straightforward. It's like C or Java.
Yeah.
But it does have ranges, and many times throughout this chapter, it says Scala supports first class, fill in the blank. And I thought that was very interesting that first class is this word that we use about programming languages. And it we can use it so much that it can seem to lose its meaning. You know what I mean? Like it says it supports first class ranges. Well, what does that mean? Like it has ranges, but what about them makes them first class?
Yeah, my only guess on it would be like it has a data structure that represents a range that that isn't necessarily like you create a range and you get an array back. Like
right.
What kind of happens in like Ruby, where you could get an array back from creating. I guess even then you get like an enumerable, so that's not even true. But
so it's like it's built in. It's a real range. It's not some sort of hack. It's not syntactic sugar.
Right. Like another thing I can think of as being kind of a first class type within a language is that we'll probably touch on is closure. It has fractional values, so you can go and like take I don't know 2 divided by 5 or something, and it will keep it at that rather than converting it to like a decimal representation. And so
that's pretty cool.
Yeah, just like an interesting feature for kind of stating like these are the things that the language kind of cares about or like prioritizes. And I mean, a range being something that Scala obviously thinks is important enough to have their own data structure for, instead of just saying this is a list or an array or something like that.
Yeah. Mm-hmm. And then it talks about the object-oriented stuff in day 1. It talks about classes, constructors. It said there's an auxiliary constructor. I don't remember that very well. Do you?
I don't think I spent a ton of time on the auxiliary constructor.
Yeah, me either. And then you can extend classes with inheritance or with traits.
Mm-hmm.
So yeah, traits.
A trait being kind of like a mix-in, like you can go.
Yeah, like a mix-in.
Mm-hmm.
So that seems pretty cool.
Yeah. One thing that really stood out to me that I haven't seen elsewhere is the notion of classes, but then also there is the object in Scala.
Oh, so the singleton.
Yeah. So it is a like I did a little bit of digging at it to figure out like what all the differences that come from it are. And an object is a singleton. Like there is only one that is accessible at a time within Scala. And the way that it kind of represents that on the Java end of things is it will actually go and if you have an object called dog and it has a def of bark on it or something, then the Java interface for it would actually be a static class with a bark method on it that was static.
Okay.
And but under it there is still an instance that it ultimately points to. And it's also known as a companion object.
Yeah, so it said that you can have an object definition and a class definition with the same name. Mm-hmm. So you would like create the class methods with the singleton object and instance methods with the class declaration.
Right.
And so I guess on the Java side it would be like just one class and then you have some static methods.
Right. Yeah, that's what I would expect it to come out as.
So
and
when
they can
when
see
we
each
say
other's privates.
What's
too.
that?
So they can see each other's private members as well. Like you have to import them, but that's one thing that they're able to do that other classes or objects cannot do.
So when we talk about like on the Java side,
mm-hmm.
what does that mean exactly to you? Because okay, I don't totally know what it means for Scala to run on the JVM. I don't think it means that it transpiles from Scala to Java and then from Java to bytecode. I think it probably just goes from Scala to bytecode that runs on a JVM. But
Right.
like, why is there some sort of like Java equivalent of everything you write in Scala?
I would have to. I guess I can't answer definitively on it, but Scala, I know, like, will compile down to bytecode to run on the JVM as like as a class compiled file. Like, if you've ever compiled Java and you get like the class output, that is the kind of intermediate bytecode from there. I mean, that's still something that can get consumed elsewhere and is exposed to the language as a static class or something. So it's not writing direct Java code, but
It's just
when
writing.
Java is interfacing with it,
It's writing
it sees
like
it that way.
it's compiling to Java bytecode. Is that
Yeah.
okay? So it's kind of like it's limited by what the JVM provides. It kind of has to use the same ideas and constructs that are in Java.
I guess it has to adhere to what the JVM provides. So not necessarily Java the language.
Yeah.
So, which they are separate things. I mean, they're in that, like, the JVM can, I don't know if you'd say, like, can do things that the Java language doesn't really embrace or support.
Yeah. Yeah, I get it. Yeah. Okay.
But
so
because it does aim to be a bridge, I think, like, they definitely shoot for having a Java counterpart.
Okay. Cool. Do you have anything else from day one?
Yes. Val versus var.
Oh yeah.
Was, I mean, I think that was one of the, it was one of the first exercises to accomplish on chapter 1. And I mean, for me, looking at it, firstly, they are annoyingly close.
Oh yeah.
Like,
one letter.
Right. And I don't know, that is one thing that I wish was a little bit more distinguished. Like, I mean, it's very much like if you're in JavaScript, there's let versus const. Like, they're very defined and different.
Yeah.
And
yeah. I kind of wish in JavaScript that let and const at least had the same number of letters so that things might line up a little bit better sometimes.
Yeah. I get what you're saying. But it also makes them stand out even more.
Yeah. And for me, let is a code smell, and so I like noticing lets and then seeing why is it a let? Could it be a const instead?
Exactly.
And it's the same thing in Scala. You want to use val because it's immutable.
I do think one thing stood out to me that that Bruce had written was that he kept saying that val was immutable, and I mean, that's only true in that the variable itself cannot be reassigned. But val makes no guarantees on the underlying object that is there, and so
it's just like in JavaScript, a const. If a const variable points to an object, you can add and remove things from that object all you want.
Right. Whereas, having worked with Rust in the past, I mean, if you have a Rust and a Rust variable and you assign it with let, I mean, that says like this and all of its bytes underneath of it are immutable. Like, you cannot change them. Like, you're not even allowed to. And then you specify let mute if you want to say that you actually do want this thing to be like a mutable set of bytes.
Yeah.
So
yeah, it's I feel like it's things like that make it Scala kind of disappointing as a functional programming language.
I mean, it's either, I guess it's disappointing, like, if you're looking at it from a complete purities standpoint, but also in some ways it can be a practical thing.
Yeah.
And if you're playing within the bounds of Scala, I mean, by default, you are getting immutable data structures. Like, if you go and create a list or a map, like those data structures aren't able to get mutated. Like, you have to create new kind of copies of them every time you alter them. Alter them.
Yeah, so that's good.
Yeah.
And so then the methods on them return brand new lists, for example.
Yeah. And they would be like persistent data structures as well, in that like they aren't going to go and make a complete copy of themselves every time you make a change to it, but instead they are going to go and, like, if you add to a list, you're going to get a pointer back to the previous list. Like you're going to create a new list with one element that points back to the previous list.
Oh, yeah, okay.
So it's not like it's going to be wildly inefficient for you to go
Right.
and add lists.
Yeah,
like that.
yeah. I never even thought about it being inefficient, but yeah, that makes sense. If it's done that way under the hood, then it's perfectly fine.
Yeah. How'd tic-tac-toe?
Oh my gosh.
Tic-tac-toe go for you?
Okay, so the only real exercise at the end of this chapter is write a game with tic-tac-toe and use classes where appropriate. And so I felt like this was one of the least relevant exercises so far in the book, where it doesn't seem to have much to do with the language other than use some classes. And also felt like it was a really hard problem just to try to use some classes as an example. So I passed on that one.
Yeah.
I wrote out a class, but that's about all.
I guess I didn't actually write any classes. I only wrote objects. So
well, that's probably good. It said where appropriate. So if you felt like it was not appropriate, then
right. I mean, I guess an object does make an anonymous class and create a single instance of it. So I mean, it
okay.
kind of is one, right?
Yeah.
But yeah, I took it on by firstly finding out about Scala's enumerations, and so I made a object called move that extended enumeration and has X, O, and question mark for its options in there.
Okay.
And then created a function that takes in a board, which is a whole list. It's a list of moves. Actually, like looking back on it, I should have done like a tuple of 9 instead. But from it, I was still kind of in the prologue mindset, and so I actually went and
I was too.
Destructured the whole, like all the positions off of the board, and then created tuples for each of the winning combinations. And I said, like, if any of these are equal, then they are a winning move.
So you got like every combination of 3 in a row, and just check if it's all X's or if it's all O's.
Right.
Nice.
And so yeah, I did that, and if it couldn't find one, then it said that the winner was unknown, because I said that I would always return, like, I reused the type of move of the move enumeration to have question mark as well. So if it didn't know, or it was unknown of a winner, then it would be question mark that came back out of it.
Interesting. Well, I thought it was interesting because it says return if the winner, or whether there's a tie, or no winner yet.
I guess I actually overlooked the no winner yet versus a board full of X's and O's.
So you just said if the X, O, or if there's a tie? Right.
Yeah, so I didn't
and I believe it's called the cat wins if there's a tie.
Yep. Yeah, I remember drawing a big C over it as a kid. But as for the actual implementation of it, of like the game itself, not just the passing it the board, I just made a program that does a while loop that says while the winner is unknown, or if the board still contains unknown, then keep on looping and ask for where you want to put it. And I just asked for an input of 0 to 8.
Okay.
It was a very programmer centric.
So this is
type of tic-tac-toe.
This is the bonus problem where you let 2 players play.
Yep.
Okay. Oh yeah. I forgot. In the first exercise, I guess the other option would be that it's an invalid board.
Yeah.
Like if there's there should never be more than 2. There should never be more than 1 X or never more than 1 O, like compared to the other
Right.
letter. Yeah, if you're taking your
Yeah.
turns appropriately.
Yeah. My tic-tac-toe was not quite that robust.
Yeah,
So maybe V2.
but that's pretty easy to just count them up.
Yeah. But overall, yeah, by writing out the list of possible winning positions and finding if there was one that did it, like it felt kind of prologue-esque, and
Yeah, I would rather write this in prologue.
that's not something you'd expect yourself to say before this, huh?
No. Okay. What about day 2? Oh, and I forgot to
Day 2.
mention that it's comparing Scala to Edward Scissorhands, and the idea is that it's I don't know if it's like it's misunderstood, and if you don't handle it properly, you're just gonna like hurt people and butcher things. But if you learn how to handle it, then you can make like masterful haircuts and like make bushes into sculptures. And
Yeah.
I feel like I'm just in the stage where I'm clumsy and I'm butchering things.
Yeah, that seems like a reasonable definition. I mean, like you have the object-oriented human-esque figure that you're familiar with, but
Right.
then you have this other stuff bolted on that doesn't necessarily seem practical at first, or like you don't really know how to work with it at first.
Yeah.
But then,
Although I'm coming at it more from the other angle, where I would probably be more comfortable with functional programming. I have not done object oriented in years since college.
yeah,
And so just to even think about trying to write a problem out with objects, I don't see the point. I just want some functions.
well, I mean, that is definitely more of what carried into part 2 or day
Day
2,
2.
in that there's a lot of discussion about the various data structures in there, like talking about lists and sets and maps.
Yeah.
And I don't know. I didn't really see anything too surprising amongst those. Like they.
Yep. I mean, it had the head and tail like Prologue
Mhm.
had, but it
Yeah.
also had the opposite from the end, and that was what were those called?
Was it like drop and init? I think.
It was something in a knit.
But
Anyway.
I believe you. With maps, I was a little bit curious of, like, they use the choice to have the arrow to say like 0 the number maps to 0 the string, and 1 the number maps to 0, or sorry, 1 the number maps to 1 the string, and it has like an arrow pointing to the right, like a dash greater than.
Yeah.
And my thought was, well, I mean, this thing is just holding on to like tuples of stuff. Like, why is it not that? When it actually turns out that that arrow operator is one that just creates a tuple of those two, and so it's actually equivalent to go and do the same thing.
So it's syntactic sugar for that.
Yeah, like whether it's syntactic sugar or it's actually like a function that goes and produces that. Like it's a
Yeah. Well, I mean the book says that it's syntactic sugar, but
yeah, look at that. And I mean, I guess it's a little bit of a win. Like it saves you like having to go in parentheses around things.
yeah, that'd be a lot of parentheses. I also thought it was pretty cool to use an arrow, like a dash greater than, instead of doing like a colon or comma or equals. It's pretty cool to think of a map saying it's a list of key value pairs, yeah, but it's this thing goes to this thing because
Right.
because you access it with the key.
Yeah, it is true. Like it doesn't generally go back the other direction because your values.
Yeah.
Like, yep. So, yeah, I thought that was interesting, and I mean, they talked about the moving from like any, and then on the flip of it going to nothing.
Okay, yeah. You're gonna have to explain that a little bit more there.
Yeah. So, any is kind of the base of everything, or it's the root class of everything. And so if you have one of those, like you don't really know what it is.
Yeah, if you have something of
And
type any, you don't know what type it is really.
right, like
But if you have a float, ultimately that is also an any. So it's kind of like float inherits from the any type.
yep, float inherits from the any type, yes. And because it's kind of the root of everything. And then on the opposite end of the spectrum, they have the notion of nothing, which is it is a type that inherits from everything.
Yeah.
It's a subtype of everything.
It's a subtype
And
of float, and it's a subtype event, and a subtype
right.
of list and map and everything.
And so like the major difference being with nothing is it's to say like you cannot use this because there's nothing to be used.
There's
Like
you won't learn
I mean,
anything from it about what type it is.
right. Like
Nothing even there's even a nothing underneath null.
mm-hmm. Yeah, and I didn't run into cases that I had to use nothing or like had to work around it, but it gave the example of like if you have a function that just throws an exception, then it has the return type of nothing, because you're not ever going to be able to use the return type of that because it just throws.
Huh. Then there's a few other confusing things because you have uppercase null and lowercase null. So uppercase null is a trait and null is an instance of it. And then you have uppercase nil, which is an empty collection.
Yeah, I have heard of that from other programming languages where they commonly have like the cons and nil. So cons being like a list constructed around that has a single value, and then nil's the empty value. So
yeah, it just seemed like a lot. Nothing, null, null, and nil.
Yeah, I get what you're saying there.
Yeah,
I mean that felt like a lot of my experience in just using Scala in general was that there is a lot to it. Like the more that I did, like the more that I uncovered of like, whoa, it's got this and this and this too. Like it's got, I mean, spoiler on day 3, but it's got like XML literal syntax.
yeah,
and a handful of other things that I stumbled into. I'm like, this would take me a long time to really get my head wrapped around. Like, I mean, some languages like IO, I mean, it didn't have a whole lot to hide, like syntactically, and right. I mean, there's concepts there, but like Scala, I feel like is one that would take far longer to actually grok and get my head around.
Yeah. It's like, oh, it's got another arm with scissors on its hands, like on
right.
its fingers.
Where was it hiding that? Yeah.
I also thought with sets in this chapter in day 2 that with sets it was pretty interesting. That has operators for union and intersection and difference, which are like a double plus plus or a double minus or a double asterisk.
Mm-hmm.
So that's pretty cool. I haven't worked a lot with sets in different languages.
Well, the set in Scala is way better than the set in JavaScript.
Yeah.
For a number of reasons, but one is like you get the whole union and intersection and things like that are really important to having sets.
Yes.
Yeah. So day 2, anything else before exercises?
No.
All right. It was a discussion on how to use Scala files. I didn't quite know what that meant other than like running it.
I didn't either. I thought at first it meant running it, but it's already talked about running from a file. So I think it means reading and writing to a file.
Oh, well, I guess I had to do that for the exercise. With the other one about the difference between what makes a closure different from a code block.
Yeah, I didn't. I don't think I found much on that. Let me see.
Yeah, that was kind of a rough one to search for me as well.
Yeah, it was very difficult. I found a lot of stuff about closures, but then they never talked about code blocks.
Mm-hmm.
So I don't know.
I would like to be called out and corrected on it, or like pointed to a definition of what it is. But the do was pretty clear to me. To fold left to compute a list of strings. I mean, fold left is commonly known as reduce in other things in other languages.
Yeah.
And
do they have fold left and fold right in Scala?
I would assume that they have right. Yep, they have right.
I mean, I don't know like why you would care which direction it does it, but maybe.
Well, I guess if you're kind of like going through and you're looking for something,
yeah.
I think it also depends too on like depending on what structure you're iterating over. Like it might be really cheap to work from the head, but really expensive to move from the tail.
Oh yeah. And
so,
there may be cases where you want to exit early, and so if you have something sorted, you want to start from a certain direction and exit early.
Right. But yeah, for me, I just took my list of strings, I mapped them to get their lengths, and then I did a fold left that added the accumulator and the next length.
Cool.
So
yeah,
it was a quick one-liner.
The next one's pretty funny. Write a sensor trait with a method to replace curse words, but he tells you the curse words are shoot and darn. Replace those with pucky and beans. Yeah. Which I don't know how pucky is a replacement for shoot, but hey.
Yeah. How was that for you?
So I actually didn't do any of the exercises in Scala. I had such a hard time trying to research documentation and write out code because I want to go back with an IDE and try these.
Yeah. I would say your experience would likely be improved.
Yeah.
Because of the assistance that you get and probably need when working through like the broad set of stuff that comes along with it. So for it, I went and made a trait that was called sensor, and I said that it was supposed to have a map of substitutions that are string to string on it as part of kind of the interface that it had to adhere to. Like I didn't go and implement what that was. And then it also took a source, which was like the string that was supposed to get translated. And then ultimately it had a toString method on it that would go and split it by space. And then it would go and map the word that it found against the substitutions list. And if it found it, then it would substitute it. Otherwise, it would get back the same word. And then it put them back together string-wise again. And by doing that trait, I was actually able to go and implement it in both ways that it asked for. One, firstly, by creating a new sensor, because you can new up a trait and kind of have like an anonymous instance of it, or like you can implement it kind of on the fly. Like I don't know if you've done that in like Java before, where you can go and like new up an interface.
No, definitely not.
But it's kind of like that, where you have to go and fill in all the blanks. So rather than going and creating a class that implemented or that extended the trait, you can actually new one up. And so I new one up that had the map of substitutions of shoot to pucky and darn to beans. And I said, shoot that darn truck. And then it translated it out to something else. And then
pucky that beans truck?
Yeah, pucky that beans truck. And then for the second one, it was doing the like newed up a sensor, but this time I got to use source from resource, which source is something that came from Scala IO, and then resources are like a Java thing where you can have a folder called resources. And I put a properties file in there, and I used Java properties to go and read from it, so that because Java properties are key value on their own. And so I mapped those to Scala, or I put those as Scala, and then ultimately created a map out of them. So I got the job done.
Cool.
Yeah, I'll share that source with you
a
little bit later tonight.
Yeah, well done.
Yeah.
Day 3, it adds a whole bunch of more stuff like you were talking about.
Mm-hmm.
XML, not only does it support XML, but it is a first class construct of the language.
Yeah.
And I thought it was really similar to how JSX looks in JavaScript with React, where you've got HTML instead of your JavaScript. But that's not a part of JavaScript. That's something that gets converted into actual JavaScript code with function calls. And this is not that. Like, this is actually part of the language. It's not
Yeah.
XML within Scala. It's Scala.
Yeah. I was kind of surprised to have seen that. Like, I think that it makes for really nice looking pattern matching, but it's
Yeah.
also like a very specific need to be like, I need to go and destructure my XML elements. But
I mean, if you're using XML for APIs, then it seems like it would actually make it really nice. Like, I think one of the reasons why XML is not great is it's hard to work with compared to JSON, and this makes it look like a lot easier to work with.
yeah, and I also, I guess I would say, like, I mean, XML is more common in the Java space too, like with the number of configuration files that are involved,
Oh yeah.
and being able to go and like pick those apart and read from them is actually a pretty critical thing. So it does make sense. Like, I mean, thinking on it more, but it's not something that that I
Yeah,
have
you would
encountered in
expect
other languages.
you would expect an XML library or something,
Mm-hmm.
not
Which
just a language construct.
speaking of that though, in order to use the XML in Scala, it is no longer part of the core anymore, and it is a
Ah,
separate library. So if you don't have Scala.xml or Scala-XML installed, then you actually wind up getting a warning from the compiler or an error from the compiler that says, hey, I understand the syntax, but there's not a supporting library, so go get it from here.
okay. Well,
So
that makes sense that you would separate that out. It
yeah.
does seem like an extra feature.
Mm-hmm.
And then it talks about pattern matching.
Mm-hmm.
It talks about how it's really, really powerful. It looks like a switch statement, but with guards, it's a lot more powerful.
Yeah, with guards and destructuring too. Like if you want to pull just some values out, you can do that as well.
Destructuring, I must have missed that.
So if you have, I don't know if they have a specific example that I can scroll down to in it, but even with where they're doing the XML matching, where they go and have a case and they
Yeah.
say like match against movie
Oh,
and then
right.
movie
Yeah.
name. So you can do the same thing with not not just not just XML, but if you have like an array and you want just the head of it, and like if you want the head and the tail, like you could go and do that by having like array brackets x and then I think colon colon xs, so for head and tail, and so you could go and do matches like that, or say like match empty list as well as match list with one item and match list with one and any number of other items.
Yeah. Yeah, I mean, pattern matching does feel like a switch statement on steroids, where
Mm-hmm.
you're not just matching a literal value. You're saying like it looks like this, or it looks like this also with this other condition. It has to be greater than 1 as well. Or
Right.
like, I don't know, with destructuring it, the XML example kind of looks like just match anything with an open and closing movie bracket, and then kind of pull out the things in between. Like, I don't care what's in between, but I want to be able to use that value.
Yeah, and that's that is it is a really nice pattern that I long for sometimes, like because it makes it easier to work with like wrapped sorts of values, or to like pull out parts of things. I mean,
Yeah.
yeah. And one thing that I wish that that Scala had, or at least I didn't figure out how to make it happen, was pattern matching in it is not like they don't force you to be exhaustive at the compiler.
Yeah.
And so like um, if you are doing a match but then you don't have a case for it, it'll actually blow up at runtime rather than at compile time.
Ooh, it's not fun.
And
Yeah,
there
so
may be a way to turn that on, but
it looks like with Scala there are compile time checks, but then there's also runtime checks and exceptions. So you don't get that safety at compile time.
I mean,
I
am glad
you get some
at least
safety.
they do have the check, like if you fail the match, like it throws right there, so then you're not unexpectedly like moving through a statement, like whereas like a switch statement, if you don't have a case for it, it just proceeds onward, like it's
Yeah.
so. I mean, it is a win on that front, but it would be even better for it to be during runtime, or sorry, during compile time.
That seems like it'd be hard to do.
Well, I mean, you will get to experience that once we get to Haskell later.
Okay.
So
Cool.
yeah.
And I think Elm is one. I don't know much about Elm, but if it has pattern matching, it I know it's exhaustive and makes you handle every case.
Yep.
And then there's concurrency, and
yeah,
I don't know. I don't have much to say about concurrency. Apparently, it's a really good thing in Scala that you can't do in Java, or it's harder to do in Java.
I mean, I guess it's less of a core construct. I mean, I say that in that, I mean, oddly though, Scala removed actors from its standard library, and instead they switched over to another one that is pretty common that I'd heard of but never played with, called Akka or Akka.
AKKA.
Yep. And it is a actor library that I believe also will, like, it'll work with Java as well. I mean, it is, but using it from the Scala side of things, like, I mean, Scala was built with actors in mind, and they were just apparently able to go and switch out the standard library for a third party one instead.
Yeah.
But
I had a lot of trouble with this. I typed the program in exactly.
Yeah.
And then it would not run. It couldn't find the imports that it needed.
Yeah. I bumped into the same thing and did some digging. I did figure out how to make Akka start working though. There was a helpful blog post by somebody making like a hello world on an older version of it, and so all I had to do was go and update my version and my dependencies to get the latest version.
Okay. Yeah, I could not figure out how to install Akka.
And that was a case where SBT was useful. So
okay. Yeah.
With that, it wasn't too painful to write, to go and make like an you have to make like what they call an actor system, which is a group of actors that work together, and then from there you tell the system that you want to create an instance of that actor, and then you can start sending messages to it.
Okay.
Yep. And
yeah, I feel like that's one of the unfortunate things about this book, or any book with code in it, is the longer ago it was published, the less likely you'll be able to type in the code and run it. And this book is only 9 years old, and so far it's held up really well until we got to this language.
Yeah. I mean, I would say like some might have more staying power than others too. Like Prolog, for example. Like, I mean, given its age that it already had at the point of writing, like, and it was in 70s. Like, I mean, like, yeah, it's still getting updated and stuff, but it's not making sweeping changes as much. Or I could be wrong, and maybe something is on the horizon. So, I did the concurrency exercise as well for going and like loading pages. And I mean, as you would expect, like going and hitting URLs in parallel is way faster than hitting them sequentially, because I mean, if you do them in parallel, then it's only the slowest website that you have to wait
and
around for.
it's not really doing it in parallel, right? It's still doing only one thing at a time, but it's just doing the next available thing instead of fully working on one website and waiting until it's done and picking the next one. If one loads fast, then it will do that one first.
I guess the way that I approached it, like it's doing it in parallel, like it's making those requests at the same time. I mean,
okay, it's doing the request. It's doing the request at the same time, but then Scala is still just running in one thread, right?
No,
Oh.
Scala will use threads to. I mean, at least the way that Akka is working. Each one of them goes and does its own thing, and I mean, I set it up so they respond back once they're done, so they all give back futures, and then ultimately, like, to go and read the values of them, I awaited them to so I can print out the value of each.
Okay.
But yeah, they are running on separate threads.
So that's another thing besides actors that provides concurrency, right? Is futures.
So I mean, a future it's not necessarily the construct that provides it. Instead, it's the representation of a value to come. So
okay.
So like, I asked an actor for something, and it gives back a future to say, okay, you can do something with this result. But future itself is not the concurrency structure. Like it's the representation of the value, but like it doesn't do the processing. So it's not tied to what makes it asynchronous. Unlike in JavaScript, where you have a promise that schedules a micro task the moment that you kick it off.
Okay.
Kind of makes sense.
Yeah, I think so. I'd have to play around with it, and I didn't get a chance to, unfortunately.
Yeah, I mean, even digging into it, it was one more of those things that uncovered some other things in Scala that this doesn't even touch on. Things like implicit parameters and implicit conversions.
Wow.
Where you can say that a function receives, like, accepts implicit parameters to it.
Huh.
So somewhere higher in your code of like a consumer of your function can, in their code at a higher level, put implicit val, and then when your function gets called, if they call it without specifying that argument, it will actually go to the nearest implicit and use that. And
weird.
Yes. And I suppose it's for making like really terse code that you don't have to keep passing the same value through for something. But yeah, that took me a little bit of time to wrap my head around, but it was part of the interfaces that came back sometimes. And I don't know. I found a Stack Overflow about it. I'll have to shoot it your way to let you have a look at it.
Yeah, I'll put that in the show notes.
All right.
Any final thoughts you have on Scala?
Well, I think it was nice to get into a static language and into a functional language. Like, I mean, I feel all right working in that place, and working with the actors kind of made me think, like, I have not spent enough time doing actor model stuff, but I think Bruce Tate kind of nailed it, and that now he's bridging, like he himself is kind of using Scala as a bridge in some regard from the object-oriented languages early on in the book. I mean, Prologue kind of aside a bit, Prologue being more in a functional realm in some bits, and bridging us into the actor model of Erlang.
In IO being prototypal, but that's just another way of doing object-oriented.
Right.
I thought that was really, really smart, how he himself is bridging the gap in this book with this language.
Yeah.
Yeah, I mean, as for me, like, Scala has a lot of really cool things in it, and I'm excited to get into the pure functional programming languages next. Let's see, I don't even know. Erlang, Clojure, and Haskell, are they all functional?
I know Clojure and Haskell are. I have not really spent any time with Erlang, so it'll be all new to me.
Okay. Well, I know the movie character for Erlang is Mr. Smith from The Matrix.
All right.
No, wait. Is that the agent's name?
Agent Smith.
Agent Smith?
Or
Yeah.
there's just replica upon replica,
Yeah, it's
and
Agent
when
Smith.
one dies, another one comes back in its place.
Yeah.
That's a good analogy. Like, I don't know much, but nice. Looking forward to it.
Yeah. Well, you can find the show on Twitter at BookBitesFM. And if you haven't given us a review on iTunes, please do that. And you can follow me on Twitter at Agarhar. And you can find Jason at Staten Jason. See you next time.
Later.